So the first algebraic method I want to look at is called the substitution method. So I got some steps written out here, and we'll go through them in just a moment. It's going to be more obvious as we go through the actual example itself. But our steps through here are basically going to be, in both algebraic methods, a way of taking a system that has two equations, two unknowns, and to somehow boil it down to only have one equation with one unknown. If we can solve the one equation, one unknown, then we can take the answer to that and plug it back in to figure out the other unknown. That's going to be our overall goal of both methods. And we're just going to look at two different ways of approaching it. For this substitution method, and we'll see why it's called the substitution method in just a moment, our first step is going to be to solve one of the equations for one of its variables, which means we have four options. We could either choose to solve to get the x in the first equation by itself, or we could solve to get the y in the first equation by itself, or we could get the x in the second equation by itself, or we could get the y in the second equation by itself. Now you'll notice I have a hint here. The hint is to look for a variable that has a coefficient of 1 or -1. In our example, that would be the y in the second equation. That one has a coefficient of 1. So that's what we actually want to solve for. The reason for that is that's going to help us to avoid fractions. Because suppose we try to solve for the x in the second equation. If I try to get the x by itself, then as soon as I divide by -3, as soon as I divide by its coefficient, I would be introducing a fraction into the problem. Whereas if I only have a coefficient of 1 or -1, then when I divide by that coefficient, when you divide by 1, you're not introducing a fraction into the problem. So that's why we want to look for a variable that has a coefficient of 1 or -1 when we're using the substitution method, because that's going to allow us to avoid fractions. And as we know, fractions suck. Step 2. So once we have one of the variables solved for, we're going to plug it back in to the other equation. So we're basically going to replace all the y's in the first equation with something in terms of x. And that way we have an equation that only has x in it. We can then solve that equation, and now we know the answer for x. Once we have an answer for x, we can plug that answer for x back into one of the other equations and get an answer for y, which means we've got an ordered pair. We've got the answer. We can check that answer back in the original. That's our plan. Let's see it in action now. So we already said we were going to take a look at the second equation and solve it for y. We would do that by adding the 3x to the other side. You'll notice that I put a star next to the equation that I'm solving for. The reason I do that is that I remember I've used that equation. When I plug this guy back into the other one, I need to know which is the other one. I don't want to plug back into myself. Because that's our next step. Now that we know that y equals 3x plus 6, our next step is to take this and plug it back in to that equation right there. So what we've got to do here, let's take a step back and see what's going on. Y equals 3x plus 6. What does that mean? That means y is the same thing as 3x plus 6. They're identical. So that means anywhere in my problem where there's a y, I could replace it with 3x plus 6 because they're the same thing. And that's why this is called the substitution method. We're going to substitute 3x plus 6 anywhere that we see a y in that first equation. So that first equation is 7x minus 3. Now instead of y, we're going to write 3x plus 6 because they're the same thing. And now we have an equation that only has x's in it, which means we can solve this equation. If I distribute that -3, then I combine like terms, then I can add the 18 to the other side, and then divide by -2. Now I have my answer for x. Once I have my answer for x, I'm going to plug that answer back into one of the other equations in order to solve for y. Because then I have y equals 3 times, now instead of x, I have negative 2. 3 times negative 2 is negative 6, and negative 6 plus 6 is 0. I now have an ordered pair. I know that my solution has an x value of negative 2 and a y value of 0. Now, it's a good idea to check your solutions. So in the first equation, if I plug negative 2 in for the x and 0 in for the y, I get a true statement. Now, it needs to work in the second equation too. So if I replace the x with negative 2 and the y with 0, hey, it works there too. So negative 2, 0 is in fact the correct solution to this system of linear equations. And this is the substitution method.